Emotions play a significant role in an individual's identity. Perceiving emotions for humans through computers is of foremost importance for a myriad of applications. By combining psychological studies with recent developments in machine learning techniques, there has been remarkable progress in the domain of emotion recognition. In our everyday life, we see humans emoting their responses through gestures, and these emotions may be anger, sadness, or surprise, to name a few. Emotion recognition has a wide variety of applications, such as robotics, building more emotionally aware machines, effective computing and human-computer interactions, and developing more human-like systems for our use. With the advent of deep learning methods, there has been significant research into emotion recognition through gestures. However, a significant challenge persists due to the lack of large data sets of labeled emotions. This is compounded by the tedious task of setting up the pipeline for acquiring and labeling motion capture data. We present a zero-shot learning-based method to account for the lack of labeled datasets for emotion recognition. Using existing gesture libraries, we extract the feature vectors corresponding to the sequence of gesture inputs, and extract the language semantics for the given emotion from language embeddings trained on a huge text corpus. By learning the appropriate mapping between gestures and language, we leverage language-based representation of emotion labels on which the network might not have been trained to classify the gestures to the appropriate unseen emotions. Our main contributions in this paper are primarily two networks: SCAAE, which is our generalized zero-shot emotion recognition pipeline, which helps identify emotions from gestures which have not been seen by the network during training. The second part of our contribution is FSGER, which is a fully supervised method to classify trained, meaning seen emotions, from gesture sequences. In our pipeline, we use the pre-trained FSGER model to extract the feature vectors from both seen and unseen gesture sequences before being subsequently used by the zero-shot framework. The paper gives a more thorough description of these two methods. Here, we present an overview of our algorithm. For a sequence of gestures, we use our proposed FSGER framework to extract a feature vector. The feature vector is combined with a language embedding vector in our deep learning framework to learn the mapping between the gesture features and the language vectors. Further, our network classifies emotions from hitherto unseen emotions by leveraging this learned mapping. Please refer to the paper for more details. Here we show some results of our algorithm. We show results on emotions previously seen as well as unseen emotions. Here we show some results of emotions that were seen previously by the network. Our approach can classify even unseen emotions with high accuracy. We obtain, in the fully supervised case, an accuracy of 77% for the recognition of seen emotions from gestures. In the zero-shot setting, we obtain an accuracy of nearly 58% trying to identify emotions, some of which have not been seen during training, which is an increase of 25 to 27% over the state-of-the-art pre-existing method on the EBEDB database. Our method is the first to classify unseen emotions from gestures in a zero-shot learning fashion.